And so this one's talking about parallelograms. I thought it'd be better to do it this way. That way you can see it as I do it. All right, so the previous video we talked about polygons, and one of the polygons was a quadrilateral. So within the quadrilateral, and we're talking about this little worksheet, within the quadrilateral, there's different parts. So today, in this video, we're going to talk about the parallelogram section of the quadrilaterals. So in the parallelogram section, there are 5 properties of every parallelogram. Okay, and the 3 parallelograms are going to be square, rectangle, and rhombus. So we're going to take a look at each one and see the properties of each one. Now, all of them have these 5 properties. Okay, we'll discuss all of them later. But we're talking about parallelogram right now. So if we look at this, the 5 properties, they're divided up into 3 parts. All right, there are properties that apply to sides, there's properties that apply to angles, and there's one property that applies to diagonals. Now, keep this in mind. It's parallelograms, it's all parallelograms, which also includes square, rectangle, rhombus. Okay, so it works for that as well. So a quick definition of parallelogram, this is actually one of the properties, is a quadrilateral 4-sided figure with both pairs of opposite sides parallel. So this diagram is going to show you all 5 of these properties. So the arrows right here, that tells you that those are parallel, and then I have these arrows also that tell you that those are parallel. All right, then you break up the 5 properties into sides, angles, and diagonals. So 2 properties of sides in every parallelogram, that both pairs of opposite sides are parallel. All right, so we just prove that with your arrows. Okay, and then the second property dealing with sides of a parallelogram, both pairs of opposite sides are congruent. Okay, so you have them parallel and congruent. So these 2 marks and these 2 marks, that tells you that these 2 are the same. They are congruent. Along with this 1 mark and this 1 mark, talking about this part of the parallelogram is also congruent and parallel to that side. So those are the 2 properties that deal with sides. If you want proofs of this that talk about how triangle congruence makes these true, then you can watch a separate video. But for the purpose of this video, we're just going to go over the properties. Okay, so the 2 that have to do with the angles of every parallelogram. So the 2 sides, and then here's the 2 angles. One of them is both pairs of opposite angles are congruent. Okay, so that's what these arcs are. You have marks for sides and arcs for angles. So this 1 arc and this 1 arc is telling you that those 2 are going to be congruent. So opposite angles are congruent, and the same thing with these 2 arcs. So I have 2 arcs here, 2 arcs here. That's telling you that those are congruent. So that's what this property is telling you. Then consecutive angles are supplementary. Consecutive would be ones next to each other. So whether I take this angle and that angle, all right, let's give an example. Say this is about, we'll say 70 degrees. So if this is 70 degrees, that means this one is also 70 degrees, right? The whole thing, angle R right here, this is R, is going to be 70 degrees, and that opposite angle, which is angle P, would also be 70. Okay, so that's the first property. Opposites are congruent. Now, consecutives are supplementary, which means if this is 70, these 2 would be consecutive. Then that would make this 110. Supplementary, if you remember, has to add to 180, which makes sense because these 2 have to be the same. Right, that's the first property. So that whole thing will be 110 degrees as well. And what we learned in the previous video, all quadrilaterals, interior angles are 360. So that's really not a property of a parallelogram. That's just true about all quadrilaterals. Okay, so I got 2 side properties, 2 angle properties, and then there's 1 diagonal property of all parallelograms. This is diagonals bisect each other. If you remember the vocabulary bisect, it means it cuts it in half. So if I take this diagonal, all right, going corner to corner from P all the way to R, that is a diagonal. All right, and I take the other diagonal, All right. They bisect each other so they cut each other in half. So that's what these marks mean, cut in half. So this 3 marks and 3 marks, what that diagonal did is cut the other one in half. So let's say the whole purple one is 20. That means from P to T, this is T, would be 10, cuts it in half, and then T to R would also be 10. So the 3 marks and 3 marks, that's what that means. Okay? And then the purple one also bisects this orange one. So that's why you have these 4 marks here and these 4 marks here. So that is showing you that diagonals bisect each other. So that's a diagram that helps you understand all 5 properties with every parallelogram. So keep these 5 in mind, because when we talk about squares, rectangles, and rhombus, those 5 are going to apply. Okay? So let's do a couple examples here. So what you need to ask yourself when you do a question is, am I dealing with the sides, the angles, or the diagonals? And that way I know what properties I'm talking about. Okay, so right here, this one, it says DG parallel to what? So DG is talking about the sides. So I'll go to my side properties. Well, the definition of parallelogram, DG opposites are parallel. So opposite DG is going to be EF. So if we actually label this diagram, you would have an arrow there and an arrow there. So DG will be parallel to EF. Okay, then DE, which again, the question is, am I dealing with sides, angles, or diagonals? DE is a side, right here. So the 2 side properties of parallelograms, so opposite sides are parallel and opposite sides are congruent. So this is your congruent symbol. So DE, opposite DE would be GF. So those would be congruent. All right, then GH. Now GH, if you look at it carefully, GH is actually part of the diagonal. So the diagonal property of a parallelogram is diagonals bisect each other. So if this diagonal DF cuts this one in half, whatever GH is going to be the same as HE. Diagonals bisect each other. So this would be HE. So again, your question, am I dealing with sides, angles, or diagonals? And that's going to help you figure out what properties you're using. Okay, 4 is talking about angles. Okay, so if you go back to your worksheet, all right, which ones are talking about angles? These 2. Both pairs of opposite angles are congruent, and then consecutive angles are supplementary. So I'm dealing with angles, but am I dealing with opposite angles, or am I dealing with consecutive angles? Well, this says DEF. Okay, angle DEF. Angle DEF is right here, this whole thing. Okay, so if we're talking about opposites, it'll be here. If we're talking about consecutives, we're talking about maybe these. What it says is congruent. Well, opposites are congruent. Opposite interior angles are congruent, so it would be that. Now, you could label it DGF or FGD. Let's go with DGF. Those would be congruent. All right, number 5. Again, deal with angles. Supplementary. Go back to your worksheet if you need to. Consecutive angles are supplementary. Supplementary, again, adds up to 180. So which one is supplementary to EFG? There's actually 2. So the question is, EFG is this angle right here. That angle right there, that whole thing, EFG. Well, if consecutives are supplementary, there's 2 consecutives. This angle would be consecutive with that. All right, so we could go DEF. All right, we'll make one of those DEF. All right, and this would also be the consecutive too, which makes sense because opposites have to be the same. So again, we'll call this F, we'll call it DGF. So there's actually two answers to that to help you out. Okay, and 6 is a good question. It kind of puts it all together. Triangle DGE. Okay, DGE would be right here, this triangle. Okay, it's congruent to what? Now, if you remember back when we did triangles, order is important. All right, so if you apply all the properties, DE is congruent to GE. Opposites are congruent. Those would be the same. Okay, and then opposite angles are going to be the same. Okay, so if you look at this and go back to triangle congruence, okay, what you're going to see, these two triangles are going to be congruent. But it says DGE. Well, I know it's this triangle, but what order do I go? Because D has to correspond to whatever letter next. So if I go side, angle, side, that goes back to triangle congruence, and side, angle, side, I know those are congruent by side, angle, side, the shortcut. Okay, but if they go DGE, D to G is the 2 mark side. So D, G, and then E is that shared side. So I go 2 marks to shared. I would have to go F, E, G. All right, because order is important. So triangle F, E, G. And a way to check that, make sure angle D corresponds with angle F, and it is. G has to correspond with E, and E has to correspond with G. Okay? All right, and you're talking about separate triangles there. Okay, so that's parallelogram with that. Same questions. Use parallelogram STU. So I'm dealing with those 5 properties. Am I dealing with sides, angles, or diagonals? All right, so number 7, you're dealing with angles, RST. So RST is asking, what is this thing right here? All right, well, based on what I'm given that this angle is 30 and that one's 25. That means this whole thing is going to be 55. So this whole thing right here is 55. All right, so based on what I'm given and what I'm trying to find, those are consecutive angles. So one of the properties is consecutive angles are supplementary. So RST, that's going to be 180 minus the 55 that I have, which is 125. So that angle is 125 degrees right here, this whole thing. Because consecutive angles are supplementary. Okay, so it says STU. STU would be here. This is number 8. Again, I'm dealing with angles. So if I'm dealing with angles, 2 properties. Opposites are congruent, consecutives are 180. So based on what I'm given and what I'm trying to find, those are opposite angles. And when I know opposite angles are congruent, so that's 55. STU would also be 55. Okay, then it asks for angle TUR. TUR. So again, I'm dealing with angles. What's my 2 properties? Consecutive angles are supplementary. Opposite angles are congruent. All right, so it's asking for TUR, which is this whole angle. You can solve this 3 different ways. You can say, all right, I know they're consecutive, and that's 55. That's got to be 125. Or we could say that's opposite, and I know opposites are congruent. So if that's 125, so is TUR. So that's 125 degrees. Okay, number 10. Number 10 says solve for B. Well, B, that's 4B minus 1 is talking about the length of that side. All right, so I'm dealing with sides, 2 properties of sides. Sides are parallel, opposite sides are parallel, and opposite sides are congruent. So I'll give this, and then ST is 23. Those have to be equal. So you set up the little equation, 4b minus 1, and you solve that two-step problem. Right, so that two-step problem tells you to add 1. So 4b equals 24 divided by 4, so b would have to be 6. So again, ask yourself every question with parallelograms. Am I dealing with sides, angles, or diagonals? Okay, so let's look at 11 through 13. 11 through 13. Okay, we're not going to work all these, but here's what I want you to understand. 11, am I dealing with sides, angles, or diagonals? When you can see 11 is dealing with sides. So what you would say is these two are equal to each other. Okay, I'm not going to work it, but you would say these two are equal. So 3y plus 2 equals y plus 20. Solve for y. And x plus 20 is equal to 3x minus 14 because opposite sides are equal, and you solve that. Okay. 12, are you dealing with sides, angles, or diagonals? Well, these are angles, so you can do it one of two ways because there's two properties. Opposite angles are the same, or consecutives are 180. Well, based on the way it's written, right, you're given x, or you're trying to get x here, and y is here, and x is here, and y is here. So it makes sense to combine your x's, which means opposite angles. So opposite angles are equal, so set that equal to each other, and set these two equal to each other as well. All right, so that's an angle question using the angle properties. 13, are you dealing with sides, angles, or diagonals? And I'm dealing with diagonals in 13. So the diagonal property of parallelogram says diagonals bisect each other. So if they bisect, that means they're going to be the same. So if I had a diagram, it would look like the marks. So 3x plus 1 is going to be the same as 4x minus 3. You set that up and solve for x. And that means y plus 3 is going to be the same as 2y minus 11. Diagonals bisect each other, set it up, solve for y. Okay, I'm not going to do those, but that's an example of how you would do it with some algebra. Okay, so that is all parallelograms. Those 5 properties apply to all parallelograms. So let's look at specifically, these are your 5 properties we just talked about. Let's talk specifically about rhombus, squares, and rectangles. Okay, so let's look at this diagram. This is a little Venn diagram which says this, and this is important to understand. If you look at this bubble, okay, that bubble has rhombus and a square in it. Okay, so what that's telling you is a square is a rhombus. And that's hard for people to understand, but what it's basically saying is every property characteristic of a rhombus fits the properties of a square. So if you're looking at the definition of rhombus, it says 4 congruent sides. Well, so does a square. Okay, but these other properties that we're going to talk about of a rhombus are also going to apply to a square because a square is a rhombus. Okay, the other side of that, you have a rectangle bubble that a square is in as well. So a square is a rectangle because the properties of a rectangle are true about a square. So a rectangle, 4 right angles, opposite sides equal. That's true in a square. Okay, so understand the idea of what's going on there. So every property of a rhombus and every property of a rectangle is also going to be applied in a square. All right, so we're going to draw some diagrams. Okay, and this could get messy. Make sure if you are copying this, wait till I get done, and then maybe go back and sketch them. Okay, because there's going to be some erasing going on. All right, but let's take a rectangle first. So look at the diagram, or you look at your worksheet. Okay, for a rectangle, you have 4 right angles. Now, on top of these 5 properties that all parallelograms have, so we're going to include all 5 of these properties, as well as 4 right angles and diagonals are congruent. So we got 7 things we're going to do here. Okay, again, don't write all this just yet, just watch, and you can go back and copy it later. So the 5 properties say this: opposite sides parallel and congruent. Opposite sides parallel and congruent. So that's the 2 side properties. All right, the 2 angle properties. Okay, opposites are equal. Now, in a rectangle, we know that that's 90 degrees. So we're going to go ahead and put a 90-degree angle there. Okay, so we have 4 right angles, and that's a property of rectangles. Okay, then second property of angles is consecutive angles are 180. Well, that's true because if both of these are 90, 90 and 90 is 180. So that takes care of the properties that have to deal with parallelograms, every parallelogram. All right, and then we have a diagonal property that says diagonals bisect each other. So a rectangle diagram would look like this. That red diagonal would bisect this. So you would have that the same as that. Okay, if we put letters here, we'll put letters here. Go RSTU. And we'll call this intersection W, intersection of the 2 diagonals. Okay, so UW, because the diagonal RT is going to cut the other one in half, UW is the same as WS. All right, other way around. RW would be the same as TW. Okay, so that's all the properties that a parallelogram would take. Okay, so if you look at the specific properties of a rectangle, the 2 that are below on the worksheet. 4 right angles, got that taken care of. Diagonals are congruent. Now this goes back to triangle congruence. Now if you want to really prove why that's true, it goes back to triangle congruence, side angle side, and all that stuff. Okay, so here's where the rectangle diagram is a little different. If the diagonals are congruent, let's say US is 20. That means RT would also have to be 20. So if I break this up, if this whole thing is 20, okay, we'll just do it real quick. If the whole thing is 20, that means each one of these would be 10, because that diagonal would bisect. Other way around. If these diagonals are the same, okay, and that bisects, that means this would also be 10 and that would also be 10. Okay, and here's why I didn't want you to sketch it just yet. If that's true, that doesn't deserve 2 marks. Both of those would have 1 mark. And that tells you that all 4 of these sections are going to be the same because the diagonals are congruent. Okay, so if you want to, you can sketch that now. So that would be a sketch of the properties of a rectangle. All right, let's take a look at rhombus. Again, the 5 properties of every parallelogram. Opposite sides are congruent and parallel. All right, this is my arrows, parallel. Opposite sides are congruent and parallel. Now with the rhombus, a lot of people describe a rhombus as a lazy square or a tilted square. So the definition of rhombus, and it's a property, all 4 sides are equal. So instead of putting 2 marks here because these are equal, we're going to put all these with 1 mark. That's just the definition of rhombus. So that's the sides of parallelograms. Angles. Opposites are the same. That's 1 property. So this angle would be the same as that angle. And this angle would be the same as this one. Opposite angles are congruent. The idea is this. If I have a right angle, let's say I do have, if this is truly a tilted square, you'd have a 90-degree angle and a 90-degree angle here, right? Well, if this tilted, let's say 10 degrees, this would also tilt 10 degrees. Okay, so if it tilted 10 degrees, this will now be 80, because it was a 90 and it tilted 10 degrees. If this was 90 and tilted 10 degrees as well, 90 plus 10, that would be 100. So that's the idea behind a rhombus. Okay, but that property, those properties of all parallelograms. So now I got the size taken care of, the angles. Now these would be supplementary to each other. So if we had some numbers in here, these would have to be supplementary. All right, and the next one, diagonals. Diagonals bisect each other. Okay, so you would run this. So this diagonal, they would bisect each other. Okay, so whatever this is would be the same length as that. And just like we did in the parallelogram, that would be true. Okay, so additional to that, right, that's all parallelograms. There's two more diagonal properties of a rhombus. All right, the first one, if you look back on your worksheet, is diagonals are perpendicular. So that means this would be 90 degrees. Diagonals are perpendicular. The next one says, again, if you want a proof of it, you can watch another video to give you a proof. Right now, we're just assuming everybody's good with just listening. Okay, so the next one, so I got diagonals bisect each other, diagonals are perpendicular, and then diagonals bisect each angle. So what that's saying is this, let's say this was 80 degrees like we had before. If this is 80 degrees, okay, that diagonal would bisect that 80-degree angle, and each one would be 40. Okay, and because opposite angles would be the same, right, this would also be 40 because it bisects that one as well. Okay, again, because consecutives are supplementary, if that's 80, this would be 100 degrees. That diagonal bisects that 100-degree angle, which would make each one 50. And again, opposites are congruent, so that would be 50 degrees as well as that one. So there's a diagram with all the rhombus properties. Now here's what gets difficult, because you go back to your diagram. It shows a square is a part of every rectangle property as well as all the rhombus properties on top of the 5 parallelogram properties. Okay, so a square, basically we're going to combine these. All right, so let's talk about the properties on every parallelogram. So I've got opposites are parallel. Okay, opposites are congruent, but we know a square, all 4 sides are the same. So I'm going to have a mark there. I'll make it a different color. All 4 sides are going to be the same. We also know in a square that these are going to be 90 degrees. All right, so that makes opposite angles the same. That makes consecutive angles 180. So that's 4 of the 5 properties of every parallelogram. All right, then the 5th one talks about diagonals. Okay, so before we get too crazy with drawing this, the fact that diagonals bisect each other, keep in mind a square is a rectangle. If you look at the properties of a rectangle, the diagonals are congruent. So I'm going to take that and apply it to a square, which means this is also true. If these are all going to be the same, let me do a different color. Because a square is a rectangle. It has all the properties of a rectangle. Okay, so on top of that, square is also a rhombus, so it has the properties of a rhombus. And look back at the rhombus, the diagonal property would be it's perpendicular, so I'll put that in the square as well. And they bisect each angle. Well, we know a square is 90 degrees. So what that's telling me is that diagonal bisects that 90. It cuts it in half. That means each one would be 45 degrees. And that's all the way around. So all these angles here would be 45 degrees. And that's a diagram with the properties of a square. But again, every time you're asking, they're answering a question, you need to ask yourself, am I dealing with sides, angles, or diagonals? And if you do that, I think it will help you with trying to figure out, all right, which one am I talking about? Am I talking about a square, rectangle, rhombus? Okay. So right now this video is talking about parallelograms. We'll have another one. Then we'll talk about the other part. If quadrilaterals, talking about trapezoids and kites. But right now, this whole video is about parallelograms. And there's diagrams of each three of those. Hopefully this helped.